Hi, I'm Josh,
Hi, I'm Ken.
and today we will be discussing about the flight control surfaces of an aircraft. So what are flight control surfaces?
An aircraft flight control system consists of primary flight controls and secondary flight controls. Under primary flight controls are the rudder, elevators, and ailerons. Before diving into the definitions of the primary flight controls, let's first take what is the center of gravity of a plane. The center of gravity is the point of balance of an aircraft. This is the exact point where you can balance the aircraft in all three of its axes. Now, what exactly are the three axes of an aircraft? Axis is defined as an imaginary line about which a body rotates. The three axes of an aircraft are the longitudinal axis, along the length of an aircraft, meaning from the nose up to the tail section. The lateral axis along the wing, or simply through the wing, and the vertical or normal axis along the height, from the top surface to the bottom surface of an aircraft. Let's talk now about the flight controls. Ailerons. Ailerons are the control surfaces attached to the outboard of the trailing edge of the wing. Both sides of the wing have an aileron which moves in opposite direction to each other. Operating the ailerons will rotate or roll the aircraft about each longitudinal axis. If you rotate the control column to the left aileron will move up and the right aileron will move down to facilitate the roll to the left. The one with the aileron down will have increased lift, while the aileron in the opposition will have reduced lift. The difference in lift force produces an undesirable effect called the adverse yaw. This is the tendency of an aircraft to yaw in the opposite direction of a roll. There are methods to counteract the adverse yaw. They are the use of differential ailerons, which is the most popular method, the freeze aileron, and the aileron rudder coupling system. Next are the elevators. Elevators are the control surfaces situated at the horizontal stabilizer, responsible for the pitch of an aircraft. Operating the elevators will move the nose up and down about the lateral axis. Pushing the control column, the elevators will move down, pitching the tail up and the nose down. Pulling the control column will move the elevators up, bringing down the tail while pitching the nose up. Last primary flight control is the rudder. Rudder is the control surface attached to the vertical stabilizer responsible for the yawing movement or the left or right movement of an aircraft. Operating the rudder rotates the aircraft about its vertical axis. Rudder is controlled by the rudder pedals. Stepping on the right rudder pedal moves the rudder to the right, causing the nose of the aircraft to move to the right. There are aircraft that do not utilize all three of these primary flight controls, and that they only use a combination of two flight controls. An example is an Ele-1, where it combines the purpose of an elevator and aileron and mostly found in tailless aircraft. Another are the flaperons, a combination of flaps and ailerons. That's it for the primary flight controls. Next is the secondary flight controls of an aircraft.
So for the secondary flight control surfaces, we can classify them into flaps, tabs, spoilers, and slats. Now remember that not all of these have to be present on an aircraft. An aircraft may possess one or at least a combination of two secondary flight control surfaces. Flaps are one of the most common on aircrafts and is usually located inboard at the trailing edge of the wing. Flaps are lowered to increase camber of the wing for greater lift and slower flight. This allows control at lower speeds for short-field takeoffs and landings. Examples of these are plane flap, split flaps, and Fowler flaps. There is also a leading edge flap which has the same function but is located at the inboard leading edge of the wing. Slats have similar effect as the flaps but is located at the wing to outboard leading edge of the wing. When slats are fully deployed, they leave a slot between their trailing edge and the leading edge of the wing. This increases the angle of attack at which the wing will maintain its laminar airflow, resulting in the ability to fly the aircraft slower with a reduced stall speed and still maintain control. A spoiler is a device found on the upper surface of heavy and high-performance aircraft. When deployed, it raises up into the airstream and disrupts the laminar airflow of the wing, thus reducing lift. At low speeds, spoilers can augment aileron function. They can also act as speed brakes that are designed specifically to increase drag and reduce the speed of the aircraft and deploy. Now, during high-speed flights, it is very difficult to hold the control surfaces in its deflected position. This is where tabs come in. Tabs are designed to aid in moving these control surfaces. Small movements in the tabs will deflect the air, resulting in a force that will maintain the desired position of the whole control surface located in the trailing edge of the wing. Examples are twin tabs, balance tabs, anti-balance tabs, and servo tabs. All of these have different functions, but they generally aid in moving the primary control surfaces of an aircraft. So to summarize, flight control surfaces control the direction of the aircraft in its three axes. The primary control surfaces are ailerons, which rolls the aircraft, the elevator is stabilator, which pitches the nose up and down, and the rudder, which yaws the aircraft left and right. The secondary or auxiliary flight controls are flaps and slats that extends the camber of the wing for greater lift and slower flight, spoilers and speed brakes to decrease lift and augment aileron function, and tabs, which helps in moving the primary control surfaces. That's it. Again, I'm Josh.
I'm Ken. Thank you for watching.
See you in our next video. Thank you. Bye.